Hello, everyone. Welcome to Study Guide Forum. Today we are looking at a question, an extract from GCE exam, that is West African School Examination, that's WAEC, private. Now we have a question that has to do with qualitative analysis. Well, before I continue, if you have not subscribed to our channel, we encourage you to do that subscription. Just subscribe in a way to encourage us to do more. So if you have not subscribed, make sure you subscribe, share, let your friends know about our channel. Thank you so much. Then we continue. Say that the table below was obtained by mixing a solution A, B, C, D, each containing zinc tetrasulfate 6, lead triazonitrate 5, sodium hydroxide, and hydrochloric acid, but not necessarily in that order. That is not necessarily in A, B, C, D. Look at the table we have here. This table is what we obtain by mixing them. So the question said identify them. Identify A, B, C, D. Identify A, B, C, D. To identify A, B, C, D, we look at the observation, what we have from all the information here. Now you note something. Sodium hydroxide has unique effect with lead and zinc oxide. It has a unique effect with them because they are what? Amphoteric oxides. So what we do here, if you look at the first column, the A column here, you notice that A plus B gives us no reaction. That is why we have a no visible reaction, no observable reaction there. And C has also no observable reaction, and D has white precipitate. In D, A missing, in D we have what? White precipitate. So if you look at this white precipitate, what does it tell you? It tells us that the compound here, the two compounds mixed together, that is A and D, they are likely to be what? One of them is likely to be insoluble. One of them is likely to be insoluble. If they are insoluble, now you look at what we have here. What we have zinc, lead, and what? Sodium hydroxide and hydrochloric acid. Zinc chloride is soluble. If we are considering this to be, let's assume that A is what? Hydrochloric acid. Zinc chloride is soluble. Sodium hydroxide and hydrochloric acid will not show much effects. There will be no change. The reaction will just go on like that, except you have an indicator to tell you when you have reached the end point. Then this is more like acid-base reaction. So looking at it like that, you notice that there will be no what? Observable reaction there. So looking at that, it's possible that what we have here is likely to be zinc ion, and what? Sodium hydroxide is likely to be also here. Now we come to this place again. We have zinc ion and what? Sodium hydroxide. So coming to this place, lead chloride is insoluble. It will give us white precipitate. Possibly what we have here is likely to be what? Lead ion. So we go again. In B plus A, we have no observable reaction. No observable reaction, meaning that no reaction, no visible reaction, nothing at all shows, which means it's likely to be also any of these things, zinc ion or sodium hydroxide ion. So coming down again, okay, now coming to this place, we have what? White gelatinous precipitate soluble in SS. Now this thing we have here is one of the characteristics of what? One of the feature to tell us that what we have here is what? Is likely to be what? Lead or zinc. Now, lead will give us white precipitate, which is soluble in excess sodium hydroxide, while zinc always give us white gelatinous precipitate, which is soluble in excess sodium hydroxide. That means what we have here is likely to be what? Zinc ion. Now, coming down to this place again, B plus B plus D, we have what? White precipitate. We have what? White precipitate. So meaning that whatever we have here is what? Insoluble. If it's insoluble, that means it's likely to also be since we have zinc chloride is soluble, sodium hydroxide will not show any effects. That means since zinc tetrasulfate 6 is soluble and zinc chloride is also soluble. So what we're likely to have here is likely to be what? Lead ion. Lead ion is likely to be present here to give us white what? Precipitate. So we go down again, have no observable reaction. White gelatinous precipitate. Here again we have soluble in excess, meaning that this column is likely to be what? Zinc. This column is likely to be what? Zinc ion. That column is likely to be what? Zinc ion. Then we come over to this place, we have again white precipitate soluble in essence. That means this place is likely to be what? What we have here is what? Lead. Because lead with sodium hydroxide will give us white precipitate soluble in essence. Here is lead. Here is also, this place is zinc. Here is also zinc ion. That means what we have here is zinc tetrasulfate 6. C is likely to be zinc tetrasulfate 6. Coming over to this place again, that means here, since this reaction is what we have at this very column, meaning that we have zinc ion here. This place is giving us white precipitate soluble in essence, meaning that is lead. And we'll come over to this place again, we have white precipitate soluble in essence. That means lead is also here. Lead ion is also here, meaning that if we have white precipitate soluble in essence in this case down here, which indicate that we have what? Lead. And also we have white gelatinous precipitate soluble in essence, which indicate the presence of zinc. The sodium hydroxide that always show that kind of reaction, which means this very place we have here is what? Sodium hydroxide. So C is what? Sodium hydroxide, because look at the reaction all through. You notice there is an observable reaction with the feature, that is a kind of reaction that sodium hydroxide undergoes with what? Zinc oxide, zinc ions. And then you notice again there's another reaction here that indicates the presence of lead, which is also characteristics of what? Reaction between sodium hydroxide and lead ion. So here is lead. So here is sodium hydroxide. So here meaning that D is what? Lead ion. That means that D should likely to be what? It's likely to be lead triazonitrate 5. So in this other column where we have zinc, notice that C is what? C here is sodium hydroxide, and here we have zinc as indicated by the addition of sodium hydroxide, meaning that this place is also zinc ion present. Now coming over to this place to confirm the presence of this lead, you notice that lead tetrasulfate 6 is what? Insoluble. That is why we have white precipitate here. That means lead what we have here is lead tetrosulfates. There will be a double decomposition that will take place. Lead nitrate ion will combine with zinc ion to be soluble, while the trace of a cis ion will combine with lead to give us white precipitate, which we have here. Now, meaning that here where we have also white precipitate is as a result of what we have here is what showing that what we have here is hydrochloric acid, because when hydrochloric acid and lead nitrate combines, you notice that the lead chloride will be formed. Lead chloride, what we have here is what? Lead chloride. Lead chloride is formed. And in this other place is a reaction that always show this is lead hydroxide that is formed. The white precipitate is lead hydroxide, which dissolve in excess, exhibiting the character of amphoteric um, oxide or ions. Amphoteric ions that always react with both acid and base to give us what? Um, to give us salt and water. So because it has a quality of reacting with both acid and base, acting like a base, if it acts as like a base when there is an acid, and act like a base when there is what? Um, act like, oh my god, what am I saying? I said, oh, it act like an acid when there is base, and then act like a base when there is what? An acid. So that is why we have this here. So we'll come over to this again. What do we have again? It seems that we have already succeeded in getting all the things done. Here again, we have our lead. So what we have here is lead 2 triazo nitrate 5, sodium hydroxide. This one is tetrosulfase, zinc tetrosulfase 6, and hydrochloric acid. So this is exactly what we have, and this is a clear picture of what is like. This is the GCE exam, that is WAEC private, an abstract from one of the past questions that should be some years back. So this a picture of what is like. Perhaps if you have not seen the nature of the exam, this is an opportunity for you to look at it. This is where, because what they do here is to give you opportunity to actually um, identify what will happen if you are actually doing the test in the lab. So look at what we have here. Thank you so much for coming this far, and I want you to subscribe if you have not, and then like. If you really want to speak with us personally, you can also go to the description column or section of this channel. You will see our Facebook page there. Visit our Facebook page. You can also talk to us through there, because you can also get a number there that you can use to call us and communicate with us directly. Thank you so much for coming this far.